This is Unit 1F. It deals with infrared and light, and in particular the difference between digital and analog communications. So starting at the bottom here, the key energy is the key idea, and from that we have electromagnetic waves, and we have light, infrared and radio. So let's have a think then about this difference between digital and analog. So first of all, an analog wave is a continuously varying wave. It can have any value at all. Obviously this is a very neat wave here, but it can have any value that we like. In contrast, digital signals have only one of two possible. It's either on or it's off, it's a 1 or it's a 0, which makes it very compatible with electronics. Now let's imagine two studios, and in both studios there's either some music playing or there's a human voice, both of which are naturally analog. The particles in the air can vibrate any which way they like. Now in the analog situation, the signal is created and it quite directly represents the sound wave. Not completely directly, but the point is, if it gets damaged like this, and the dotted lines here represent the damage, the message and the signal are very much tied together. So the poor old radio can't distinguish between what's supposed to be there and what's been picked up, what extra bits, what interference have been picked up. So the wave, the sound wave it creates with its speakers may well be damaged. Now with the digital situation, some aspects are similar in that the wave will still get damaged. This is a common mistake. It's not that they don't get damaged, they do. We can see the damage here, but the radio can repair the damage or can clean up the data, we say. So in its little digital mind, it thinks either is it a 0 or is it 1. So something slightly damaged, it was 0, it's actually gone up by a fraction, it still turns it back into a 0, and likewise with 1s. So it can turn it back into the original intended signal. So it gives a very clean sound wave, very, very close to the original. So key idea here, analog waves get damaged, digital waves get damaged as well. The difference is that the receiving machine, the radio or computer, whatever it is, can clean it up, can tell what's nonsense and what was original message. So let's have a look at infrared here. We've already mentioned previously remote control, so you can't see it, but you can send a signal. We've obviously illustrated it here to your TV amongst other things. We've already talked about total internal reflection and optical fibers. One specific way that information is sent is through multiplexing. What does that mean? Sounds very complicated. It isn't really. So we've got three signals coming in to our control box here, and the way we can send lots and lots of conversations through one piece of optical fiber is to very rapidly switch between these, maybe a million times a second, so a millionth of a second or 10,000ths of a second. And then at the receiving end, this is then unpicked or unparceled and put back into the various conversations and data streams. Then we also have thermal imaging. So here we've got an example. Police are chasing some kind of criminal, and we can get all kinds of information that we can't get from visible light, how warm an engine is and so on. So there we have it, infrared light, and probably the hardest thing here is the analog and digital idea. So have a good look at this image and make sure you know what the differences are.